Everyone, so today we are going to solve another interesting problem number 7, reverse integer. And it is said in the problem given are two 32-bit integer x, return x with its digits reversed. If reversing x causes the value to go outside the 32-bit integer range, that is minus 20 minus 2 raised to 31 to 2 raised to 31 minus 1, then return 0. And it is mentioned in the problem that assume the environment does not allow you to store 64-bit integers, signed or unsigned, and the integer x could be a positive integer or a negative integer, and we want to return the positive reverse and the negative reverse as well. Okay, and let's look at the constraint. So the constraint is just our number is between minus 2 raised to 31 to 2 raised to 31 minus 1. Okay, so what we'll do is we will have a number x as 1, 2, 3 or minus 1, 2, 3. Then what we'll do is, so first thing what we'll do is we'll make our number as always as positive, which what it does is that irrespective of the fact that if x is less than 0, then we'll make it positive by saying that this is taking the negative of the number, otherwise it's just x. And then we'll reverse this number using one function to reverse the number, and then we'll check the range for this reverse number, that if it is between minus 2 raised to 31 to 2 raised to 31 minus 1, then it means this is our valid number, and we'll return the reverse if based on the sign that we have. If x is negative, then we'll return the negative of the reverse so that we have the positive number back. Otherwise, if it is positive, then we'll return the positive reverse. And in case we don't find anything, then we'll return just 0. So this is the if condition and this is the else condition for it. And now for reversing the number, what we'll do is like how to reverse this number. So we have this, I think from high school maths, that how do you reverse a number. We will use the same logic to reverse the number, that we'll divide it by 10 and we'll store the quotients and remainder. So this becomes 120, and we'll store this quotient and remainder to make the reverse number back. So this is for the first iteration, and the second iteration what we need is we will again divide 12 with 10, we'll get 1, and so this is 2. So we'll again store these to make our number back, and then in the end we'll divide it with 1, so that is 0. So this is 0, this will become 1, and this is q2, quotient 2 and remainder 2. So to make our number, what we need is we need 3, and how many times we are doing the iteration, 10 is to 2 times, plus then we have 2, 10 is to 1 time, and then we have again 1 into 10 is to 0 time. So in algorithmic way, what we are doing is basically we are having this number, and until this number, so this until this number is greater than 0, then what we are doing is we are finding out the remainder, and then we are using this some variable 0 to using variable one answer to do the mathematical operation that we are doing, and adding the remainder into it, and then we are again dividing the number with the 10 to get the quotient, and in the end we will return this whole number. So remainder we are getting by doing the modulus operation with the number. So number modulus 10, and then we are adding the number and storing it in one variable, and again number we are getting by division. So this would be our approach for writing this problem, and now let's get into the coding part of it and see how we can write this in coding. And we will use the logics what we have written, so we are going to need that. So like we decided, first thing we need is we need our number. So the number is x, negative of x, if my x is negative, otherwise it is positive of x. And once we have, then what we'll do is we'll store the reverse of the number. So our number would always be positive, so we'll name it as like positive reverse, and this function will give us the reversed value, and then we'll check if this reverse is within the range that we are looking for. So it is between 2 raised to 31 minus 1, and or it is greater than equals to 2 raised to 31 up to negative. Then what we'll do is we'll say that yes, this is the number we want, and we'll return the negative of reverse if my original number x was negative, otherwise we'll return the number as it is. And in case we don't find anything, then we'll just return 0 as said in the problem. And now we want to write our positive reverse. So this is going to be our positive reverse, and we'll rewrite the algorithm that we discussed for this. So we need one self also because we are outside, and we need to do self dot positive reverse in the main reverse function. So here what we'll do is we'll declare one answer variable which will have the reverse of the original number, and we'll say until the number is not equals to 0, then we need to find the remainder. Remainder is number modulus operation 10. This gives us the remainder, and we'll store the remainder with the reverse of the number. So this is the process. This is where we are reversing the number with its part, and we need the quotient again. So that is number by 10. So this gives us the quotient, and in the end we'll return the answer of the reverse number, so which is the answer variable. Now let's submit our code and see how it performs. So let's run it for one test case. So it has been accepted for all the test cases, and now let's submit our solution and see how it does. So that has also been accepted, and it's running pretty fast. And this is the algorithmic way of solving this problem, and we are not stored any number in the 64-bit signed or unsigned, and this is the algorithmic way of solving this problem. And the time complexity for this is O of just the operations, number of operations. So that is O of basically we are how many times we are doing the divisions. So O of the number of divisions that are happening. So that is the time complexity, because that is the only thing which is doing the iterations, and the space complexity is O of 1 because we are not storing any list or anything. So the number of iterations happened, so for this is 3. So as for other number is 3, and if the number is long, then it would be long. So this is the time complexity. So yeah, that's how you solve this problem. And if you guys are liking my video, please like, share, and subscribe to the channel. It helps me into creating more such awesome content for you guys. And if you have any particular problem request, please let me know, and I will share the algorithmic solution for that. And thank you. Have a nice day.